Hot air balloons are amazing. They seemingly defy gravity to float above the ground. Obviously they require the burner in their baskets in order to function, but why would heating the air in the balloon cause it to rise? In 1787, Jacques Charles formulated a law which explained this phenomenon.
Charles took 5 balloons, each filled with a different gas. Each balloon initially had the same volume and pressure. Charles heated all 5 balloons to a temperature of 80 degrees and noticed that their volumes had all increased by the same amount. In addition, when Charles heated the balloons to higher temperatures and cooled them to lower ones, he found that there was a constant proportionality between the volume and temperature. Therefore, he concluded that the absolute temperature of a gas is directly proportional to its volume, or in other words, V is proportional to T. Charles didn't actually publish this result. Instead, Joseph Gay-Lussac published it in 1802 and credited the law to Charles. Charles's law can be used to explain that when the air in a hot air balloon is heated, the total volume of the gas which was occupying the balloon must increase proportionally. Hence, some air must leave the balloon when it's heated, decreasing the density of the air in the balloon. The decrease in density produces a buoyant force upwards on the balloon, lifting it into the air. Charles didn't invent the hot air balloon, but he did pioneer the invention of the hydrogen balloon with the Roberts brothers, based on his understanding of Boyle's law. He used hydrogen because it was lightest for its volume. It was least dense. Suppose I have a spherical balloon of radius 5.0 centimeters at 25 degrees Celsius, and I heat it by exposing it to hot water at 100 degrees Celsius, to an error of plus or minus 1 degree. What is the new radius of the balloon, assuming that the compressive force of the balloon doesn't change significantly? Applying Charles's law, the initial volume over the initial temperature is equal to the final volume over the final temperature. Rearranging gives that the final volume is equal to the initial volume multiplied by the final temperature divided by the initial temperature. The volume of a sphere is 4/3 pi r cubed, so 4/3 pi r2 cubed equals 4/3 pi r1 cubed multiplied by the final temperature divided by the initial temperature, where r2 is the final radius of the balloon and r1 is the initial radius. Cancelling factors and taking the cube root of both sides yields r2 equals r1 multiplied by the cube root of the ratio between the final temperature and the initial temperature. Substituting in values gives that r2 is equal to 5.4 centimeters. But don't forget that we simplified the problem by neglecting the compressive force of the balloon.
Jacques Charles was trained as a clerk in the finance ministry and grew an interest in science. He experimented with electricity and he invented several measuring devices, such as the hydrometer for measuring the density of liquids and the goniometer for measuring angles, and improved existing devices such as the heliostat. Charles was also one of the first to fly hydrogen balloons, and in some flights he rose to more than 1 kilometer above the ground. He was a member of the French Academy of Sciences, and as a result became a professor of physics. His published papers are predominantly mathematical, but many have been misattributed to him instead of another J. Charles. I guess you could say that after Charles got involved, the development of gas laws started heating up.